So just kind of rehashing what we did on Wednesday, okay? We were talking about compound inequalities, okay, which is inequalities that consist of two distinct inequalities, okay? So you're going to have two inequalities that you have to solve and then graph those solutions together, and depending on the word and or the word or will tell you then how you choose your solutions. Okay. The main thing that we talked about, if we use the word and, okay, that means an intersection for us, and maybe a more kind of generic word is overlap. Okay, so we'll be looking for where they overlap. So here we've got x is greater than or equal to 3 and x is less than or equal to 7. So all we do is we graph x is greater than or equal to 3, and that's this first graph. We graph x is less than or equal to 7. That's the second one. And now because there's that word and sticking those two things together, we're going to look to see where those things start to overlap. Okay? And they overlap between 3 and 7. So this here, this last graph, let me circle this. This last graph is representing that statement right there.
I don't think I was here.
I currently don't have a printout. Okay, so I can email you one, but it's gonna be in a couple minutes. So we did some examples like that. Okay, now I want to work basically, Travis, you just get paper and pencil out, and you can. There's not a whole lot more notes that we're going to do here. We're just going to do practice problems. So we did that with the word and. The and was the overlap, okay, or the intersection. The word or meant that we graph, again, two separate inequalities, and then our final graph is just the combination of everything, okay? So everything from the first graph along with everything from the second graph. So those were the ideas we talked about on Wednesday. Those of you that missed Wednesday, I would suggest getting online, looking at the video from 3.6. I'll post this video right next to it as well. But if you watch that one, a lot of this stuff will make sense. This here is a special type of and statement. Okay, what we're saying here, basically, we're going to read these normally left to right. We'll say -9 is less than 3m plus 6, and 3m plus 6 is less than or equal to 18. Does that kind of make sense how I said that? Okay. So I'm going to say this statement here. -9 is less than 3m plus 6. Then I'm going to say the word and 3m plus 6 is less than or equal to 18. So there's really two inequalities there. Okay, the yellow one and the blue one. Does that make sense? Okay. Now, I'm going to separate these real quick. You don't have to do this. I'm going to separate these to prove a point. If I had -9 less than 3m plus 6 and 3m plus 6 less than or equal to 18. That is what this stuff over here that I highlighted is actually saying to us. Does that make sense? If I look at that first inequality, -9 is less than 3m plus 6. How do you get the 3m by itself? You subtract 6. And then you come over here and subtract 6, right? Keep that in mind, because now we're going to jump over to this one. What would you do over here to get that 3m by itself? Subtract 6 and subtract 6, right? It's the same in solving inequality number 1 or inequality number 2. The first step is the same, right? Once you do that, will you then divide both of them by 3? Yeah. Okay, so here's my argument. Why separate them? Why do this? If the work is going to be the same for both of them, why can't I just come over here and say, if I'm going to isolate that 3m, you know that you need to remove that 6, right? Well, if I remove 6 from over here, that's doing what I just did right there. Does that make sense? Remove 6 from the 9. No, the -9. If I remove 6 from the 18, that's doing exactly what we did right there. So let's do it all together right here. So my argument is when you see one of these statements where it says -9 is less than 3m plus 6 is less than or equal to 18, you've got an expression in the middle. you're going to try to isolate the variable in the middle by removing, in this case, the 6. You do that to not just one part, you do it to all 3 parts. Okay? And this is going to allow you to solve your inequalities simultaneously. So what's negative 9 minus 6? Negative 15. I've got my less than sign. Now I'll have just a 3m in the middle. And what's 18 minus 6? 12. Okay? So now I get that inequality. Negative 15 is less than 3m is less than 12. Well, when I'm graphing, I don't want 3m, I want 1m, right? So how do I make that 3m turn into a 1m? Divide all sides by 3. Divide that by 3, divide that by 3. Divide that by 3. What's negative 5 divided by, or negative 15 divided by 3? Negative 5. Less than m, less than 4, right? Now, the reason I like doing it this way, because you could, let's just kind of go over here to the side real quick. If I would have done that over here, this would have been negative 15. Negative 15, less than 3m. Would that give you negative 5 is less than m? And over here, it gives me 3m less than or equal to 12. Would that give you m less than or equal to 4? Is that, it should be less than or equal to, is that the same thing as that right there? Is this here the same thing as that right there? Does that make sense, everybody? So you can do it either way. Now, why do we want to do it the way I've done it in blue? Is the reason because if I did it in red, I got to graph both of those individually and then look for the overlap. Okay, so I have to have 3 separate graphs if I was going to do it. If I was going to graph this the way I did it in red. If I'm going to do it in blue here, it says m. Can we make the argument that m is between negative 5 and 4? Does that make sense? M is that middle thing, right? M represents all of our answers. We're saying it is greater than negative 5, but less than or equal to 4. So that means it's between. That structure right there allows me to find negative 5 on my number line, positive 4 on my number line. What kind of dot do I use at negative 5? Open. What kind of dot at 4? Closed. And now because m is in the middle, negative 5, first thing, m, second thing, 4, third thing. M is the middle, right? This structure says then, well, then m has to be a number like that. It has to be between negative 5 and 4. Or maybe it has to be that number. Or maybe it has to be that number. Doesn't it mean it could be any one of these numbers in between 0 to 4, or negative 5 to 4? So because m is in the middle, once I find negative 5 and 4, I can just shade in the middle of those. Okay? And that eliminates me having to graph 3 graphs. Okay? If you were doing it, well, I'll just do some purple over here. If I were to do the same thing, so let's graph that thing right there. Negative 5 is less than m. So that would be that stuff right there. Does that make sense? Maybe I write as m is greater than negative 5. If I graph m is less than or equal to 4, that would be that stuff that direction, right? The word and, at the beginning we said we look for the overlap, right? Where do these purple ones start overlapping? At negative 5, and they stop overlapping at 4, right? Is that exactly what we have right there? So writing these as what we call a between statement, that's 3m plus 6 in the beginning problem. 3m plus 6 is between negative 9 and 18. Writing it that way gives us a solution at the end that is very easy to graph. Okay? Does that make sense? Okay. Let's do this next one. I'll let you start this next one. 3 is less than 4p minus 5, less than or equal to 15. Give that one a go. I'll come back and discuss that. Oh, sorry, wrong button. I know. There we go. All right, so the key thing here is the word or, right? The word or tells us you have to do that inequality. You have to solve that one individually by itself. Then you have to solve that inequality individually by itself. Okay? So when I do the yellow one, what is the first thing you're doing the yellow one?
You are adding subtraction 1.
Subtract 1. So I have n is less than or equal to -4, right? Okay. Now come over to this purple one. What do I do there? Thank you. Divide by -4. Divide by -4. Now, when I divide -4n by -4, I get n, right? What's -8 divided by -4? 2. When I divide by a negative, what do I have to do with that thing? Flip its direction. Okay? Now this word or should be carried through the process. So I now have a solution that says n is less than -4, less than or equal to -4, or n is greater than 2. So if you remember what we did last week, we took 3 number lines. Okay? And the bottom one was our final answer. Let's write final answer down here. Light just flash? Okay. So what I'm going to do, I'm going to try to make these number lines so that they all have that 0 on them. I'm going to put 2 there, 2 there, 2 there. So now 1, 2, 3, 4. All right, so -4, -4, -4. Okay, it's a lot easier when the number line's already made for you. But what we need to do is we graph these individually. We graph n is less than or equal to -4. Okay, so at -4, what kind of dot do I use? Closed. And now which way do I graph? Left or right? Left. Okay. Now on the next one where it said n is greater than 2, I go find 2, open or close dot? Open. Now shade which direction? To the right. Okay. So now, when we are going to come up with our answer, the word or tells us what to do. If it was and, we look for the overlap. If it's the word or, we include all of the first one along with all of the second one. Because remember, when we pick a solution, we pick an answer out of that number line, out of that final answer number line. So give me a number like 5 over here. I said give me a number like 5. So let's use 5. So if I choose 5, it's going to work for the yellow one, or it will work for the purple one. It doesn't have to work for both. Does that make sense? And it won't work for both. If I plug 5 in, it's 5 plus 1 less than or equal to -3. No. If I plug 5 in here, it's -20 less than -8. Yes, so it worked for one of them, right? It works for either this one or it works for that one. If I plug a number in from this side, so negative like 10, what's -10 plus 1? Is that less than -3? Yes, it works here. It does not work in the purple one, right? So solutions off our final, basically where we graph those purple arrows, okay, that is saying those solutions will work for one or the other of your original inequalities. Okay, you remember doing that last week? Was it on Wednesday? Okay, well, if you weren't here on Wednesday, you're not going to remember it. Let's do... do that one. If you wanted to, you could rewrite this as -33 is less than or equal to -7n minus 12, and 7n minus 12 is less than -26. If you want to do that as two separate inequalities combined with the word and solve those two things individually, you can. But the argument is, well, in that first inequality, I'm going to add 12 to both sides and then divide both sides by -7, right? Are you going to do that in the second one as well? Are you going to add 12 to the bottom one there, to both sides, and then divide both sides by -7? I forgot to put a negative on that 7. But you're going to do the same thing. So the thought is, it might not be, in regards to solving, essential to do that. Let's just add 12 to all three parts. Okay? So what's -33 plus 12? -21. Less than or equal to -7n. Less than, add 12 to there, this gives me -14. Okay? Now what am I going to do? Divide by -7. Okay? So it gives me 3. Terrible color. Looks good on my screen. -7, -7, -7. So I'm going to divide, I'm going to get 3. What's -14 divided by -7? 2. Okay, now, what I need you to understand is that this should mimic a number line. It's 3, so the number to the left should be smallest, and the number to the right should be the biggest. Is that the case here? No. So, what did I divide by? A negative. So what's that tell me to do with those signs? Flip them. So this one needs to be pointing that way, and this one needs to be pointing that way, right? Okay, so that's better. That's better, but in what we call a between statement here, when n is between two numbers, your arrow, if we look at our inequalities as arrows, they should always be pointing to the left. So if I kind of turn this whole thing on its, basically use the symmetric property and flip the whole inequality, I should have 2 come first, 3 come last, n in the middle. Does that make sense? Now that right there should be being stated right here. So what should my inequality be pointing to, the 2 or the n? The 2. Because it's pointing to the 2 up here, isn't it? Down here, this inequality should be pointing to the n. Now do we see that thing as a number line, smallest number first, largest number second? Okay. And now if we graph that, we're going to find 2, find 3, open or close at 2, open, close at 3, right? And then shade in between. And all these values in between represent your n, represent your answers. Is that okay? All right. I want to do one more and statement. Let's do that one. Okay. Now, this one, it's got the word and in it. Okay. But it's different than the one that we just did. Because the one we just did had a common expression, had a -7n minus 12 in both of the individual inequalities. Do you see -10 minus 2v in both those inequalities? No. Do you see 6 in both those inequalities? You see a positive 6 in both these inequalities? You only see it in one, right? Do I see 6v plus 12 in both those inequalities? No. Do I see -6 in both those inequalities? No. So I can't merge those like I did previously. I guess coming back up to what we stated in the notes. Like at this stage right here. This is saying a similar inequality, but they both have m minus 4 in them, right? Yellow one has m minus 4, green one has m minus. They have something in common. So then I can merge them into something like this. If they don't have anything in common, I have to solve them individually. Okay? So solve those individually. What are you going to do first here? Okay, if you subtract 6, there's nothing wrong with that. You're getting negative 16 minus 2v is less than 0. It makes more sense to add 10. Subtracting 6 isn't wrong, but adding 10 is probably better. So we add 10 to both sides. We're going to get negative 2v is less than 16, right? Now what? Well, keep solving for v here. Divide by negative 2. It's going to be v. Switch the sign. Divided by a negative, so you got to flip the sign. So v is greater than negative 8. Is everybody okay with that? Okay. The word and should be here. And now let's solve this one over here. So solving this one, what would you do first? Subtract 12. So we get 6v is less than negative 18. Divide by 6. V is less than negative 3, right? Now think about this. Now we can graph this. So let's do this. Because now I've got it written as two inequalities, it makes sense to graph them separately. So let's graph V is greater than negative 8. And then we'll graph V is less than negative 3. If negative 8 is right there, and maybe negative 3 is right there. So V is greater than negative 8. What kind of dot do I use? Open. And now I'm going to shade which direction? To the right. Okay. Now, this one says V is less than negative 3. What kind of dot at negative 3? Open. And shade which direction? Left. Okay. Now, the word and says what are we going to do when we want to graph the actual answer?
You put them both on it.
I don't put them both on it.
You put the overlap.
I put the overlap. So the overlap is between negative 8 and negative 3. Now they're both open dots. And we're shade in between. Okay? Now, let me ask you a question here. If that's in between, couldn't I say negative 8 is less than V is less than negative 3?
Yeah.
That's another way of writing that. They both now have V in common, right? So I put V. I figure out which one was the lesser number? Negative 8? Which one was the greater number? Negative 3. If I'm looking at the V is greater than negative 8, the inequality is pointing to the negative 8, right? Let's point it to the negative 8. Here, the inequality is pointing to the V. Let's point it to the V. Does that give me exactly that? Okay. So, I know there's a lot of notation stuff here, and this is one of the things that people struggle with the most, is being able to jump back and forth between them using the verbal word and then them combine it into basically this between statement, where we've got a number, an inequality symbol, a statement, an inequality symbol, and then a number. Okay? But we need to be able to bounce in and out of both those. Is that okay? The assignment from last Wednesday is still open. Okay, I'd like that to be. It's going to close off tonight at midnight. Okay, just keep working on that.
I didn't know it was open.
If you don't get it done tonight because you weren't here Wednesday, okay, just let me know tomorrow to reopen it for another day for you. I think it would be in your best interest, though, to try to get it done before tonight.